Yes, we are live. Hey guys, welcome to the fourth episode of The Code Rush, a dedicated show for developers with live demos and practical examples on DevOps and cloud native concepts. I'm your host Pawan, and I have with me Om Prakash OP as another host to manage the show. Hey OP, how are you doing today?
Hey, Pawan. I'm doing well and super excited for today's show. How are you?
Cool. I'm doing amazing. I'm doing amazing. So OP, who is our guest today, and what are we going to talk about?
Yeah, we have an interesting guest for today's show. Our guest for today's show is Ravi Lackman. He's a product manager at Harness, and prior to Harness, Ravi was the field CTO at Shipper, leading advocacy and solutions engineering. He has also held various sales, engineering, and advocacy roles at Harness, AppDynamics, Mesosphere, Red Hat, and IBM, helping commercial and federal clients build the next generation of distributed systems. Most importantly, and it's a fun fact about him, he enjoys traveling the world with his stomach and is obsessed with Korean barbecue. Hey Ravi, welcome to the show.
Hey, what's going on? Hey, OP. Hey, Pawan. Thanks for having me on.
Cool, Ravi. Welcome to the show, and we are very excited to have you. And it's very important to know and understand what is happening behind the scenes after an application has been deployed successfully. So, I believe that is where observability comes into the picture. So, let us dive deep into the fascinating world of monitoring and observability with our guest Ravi. Hey, Ravi. So, my first question to you is, how would you define observability, and why is it important for developers?
Yeah. Observability. It's been around for a while in manufacturing, but it's been boiling into software, right? You might see it shortened like O11Y or OLLI, one of those shorthand things. Observability. But let's take a non-computing example, and then we can talk about like how observability kind of articulated into the software world. So let's say you have a car, right? And say you bought a new car, and you're looking at the door, and like these things are, I like to call panel gaps. Like you tell like quality of a car if like all the space between the doors are equal. If you go to the left side and right side, if they're different, you might say, you know what, this is not a good quality car. Why did I buy this car? Let me send it back, to get fixed, or I should have bought another one. And basically, what you're inferring there is the quality of the car based on what you could observe externally, the panel gaps. Now, you weren't there when they put the doors on. You weren't there when they cast the aluminum or the carbon fiber for the doors. You're just noticing how it is at the end when you went to go pick it up, right? Or went to go buy it. The kind of the manufacturing definition of observability, or OLLI in tech days, is you're inferring the internal state of a system by external metrics, or by the external systems are inferring your internal state of your system, right? So the car door example is external. You're inferring that the manufacturer, not naming names, I didn't do a good job. Or on the flip side, if the panel gaps are exactly the same, it's not one of the reasons I say this is I do this when I buy a car. It's like, oh yes, they did a good job building this car. If they've got these things covered, not worried about kind of the later stuff. And that's basically it. Now, kind of swinging to the software example, right? So there's three pillars of observability, and some people might add a fourth in there, but we'll keep it simple. And it's things that I think as a developer you notice or you don't notice, and a lot of times it's like the DevSecOps movement. You worry about these things after the fact, or you say yes. So I'll talk about the pillars, and then we can, this might be a long-winded answer or conversation on why is it important, why is it not important for a developer. There's three pillars, right? So typically when you're writing software, you kind of deal with logs to begin with. Now, if you're building a distributed system, there are these things called traces. But if you're focusing just on one service, you're a developer, you're building a piece of functionality, it's a exercise in iteration. Like you're constantly looking at the console output, you're constantly looking at the logs, let it be distributed logs or like just on your local machine, and saying, oh, okay, like did something occur that I expected? Did I add two numbers together right? Or did I get a response back that I was expecting? Or did I give an error that I was expecting or not expecting? And that's in the logs. And as a developer, like you're very good at like seeing your local logs. Now, as we all know, it's at some point your idea has to get off of your machine. It's like if a tree fell in the woods, did anybody hear it? Well, if it's only on your laptop, is anybody using it? Right. And this is where like just the volume and influx of this data kind of increases. And so looking at monitoring a system as a whole, so now you're not just worried about your particular feature, you're worried about how your features interacting with other features, or how your features interacting at scale. And this is where metrics come in, right? So after you leave logs, the second pillar is metrics. So like, okay, like what is a metric? Might be average response time, or something called ART. Or there might be something, what our metrics are, we're looking for infrastructure related metrics. What is our CPU pressure, memory pressure, or are we, overburdening any part of the infrastructure but what we're doing? And then the last thing, especially with the distributed system, there's this third pillar called traces. So even something that we're using today, like we're using, in the for us talking with this video sharing platform, there's dozens of services, like that what we traverse. Like, how do we capture the user journey through all these systems? Back before there were traces, we had to go and look at multiple log files. Like, oh, here's a log file for the app server. Here's a log file for the database. Here's a log file for another app server because we have multi-nodes. Here's the web server. Like, and you have to kind of figure out, you try to GUID someone out, but it comes at different times versus like a trace. It's you can actually kind of, just like the word is saying, if you wire it in a certain way, that you can actually follow the distributed user journey throughout your transaction matters. And so that's kind of it. Like, observability, you're inferring the state of your internal system by looking at external systems. So that can be a logging solution, that can be a monitoring solution, that can be a tracing solution that you have. And that's basically it. So I know I kind of gave a long-winded answer, but hopefully it was.
No, I think it's a perfect way to start explaining what is observability from cars, because I think Toyota is one of the best example. They started all this in a production line. At the end, if there's a mistake, they'll stop the complete car production and they start rebuilding it from scratch. And then, even in the software's world, like you said, observing the internal system and checking for the external data or events for improvements. And in industry, people confuse observability with so many other concepts in the ops world. So this question, I think you can help with this. It's how does observability differ from monitoring and logging?
Yeah, it's kind of like observability is like a science, right? Like it's a term that's kind of thrown around. Like I live in Atlanta, and every soda is called a Coke, or it's blurred out. So yeah, every soda is called we call it Coca-Cola. It's an eponym, right? Like observability sometimes can be confused with eponym. Like, oh yeah, we our observability, we have observability. Like, it's not like DevOps. Like, you check a box. We have Jenkins. We have DevOps. Or we have Harness, as a C solution. It's a science, right? So observability, it boils into like reliability science. Like, hey, can you infer the state? Going back to the course manufacturing definition, can you infer the internal state by looking at it externally? The logs and metrics are very prudent to you be able to say, yes, we are able to observe what's going on because we're backing it with logging data, we're backing it with metric data, and also if you take traces into it, we're backing it with trace data. Right? So observability, it's more of a concept, right? There's like clearly there's observability vendors out there that will sell their solution or their platform, or say, yes, you will have full observability with a magnifying glass if you purchase us or use our product or project. But those are pillars, right? So like not one or the other will give you observability. It's helping you build a case if something does go wrong, or validating if something is right. Right. On the flip side, like we also want to validate if we're correct, and having a proper set of metrics, logs, and traces will help you gather that.
Yeah, Ravi. So, yeah, I really liked when you said observability is like a science, and most of the developers are nowadays more interested to know what's happening after the deployment of their applications. So, I would like to know, like we and the viewers would like to know, what are some key practices and techniques can developers adopt to improve the observability in their applications?
Yeah, it comes back to like just knowing it's there. Right. And so like, let's, in my background, most of my career, I've been like a software engineer, and then I kind of switched over later now to the product. And so it goes back to about how much it's this concept I like to call like the fog of development. It's it's a play on the fog of war, right? And so it's situational awareness that you have. And so when you're building something, let's start small and start big, right? And then go bigger into the bigger picture. You're building a feature, right? So we say it's Pavan's calculator. We need to make sure that we were adding a new addition feature. So we only had subtraction and multiplication, but our users told us, well, we need to be able to add some numbers together. It's like valid use for a calculator, being able to add. And so we'll go and build a feature, and we're like hyper focused on, okay, let's make sure we add, let's make sure, we cover, someone can't, can we add a real number, unreal number? Can we add a letter? Like all these like test cases and validation and specs used, but you're just hyper focused on that. Now, what we didn't say is that, Pavan's calculator actually gets as much traffic as the Google homepage, right? It's the first thing you see when you open your laptop is the Pavan calculator. And so that kind of brings like a whole bunch of other variables that, as a developer, I built the addition feature, but am I responsible for the scale? Am I not responsible for the scale? It's a merge of what's happening today, right? Like, again, long-winded answer. It's more of a kind of intrinsic answer. Are you responsible or are you not, right? So I would say if you were not responsible, so the full lifecycle developer model, the operate and build, you operate what you build or you run what you write. If that isn't quite there, like you might say, you know what, I have a log. I put appropriate log statements. I don't care where they go. It's not my problem. Like I was told to use this log interceptor or log aggregator, and that was it. Like it's up to the platform team to worry about that, which is fair, right? And depending on the language you're using, like it might be, hey, you know what, we wrote this in Go or we wrote this in Rust. We have a way, like the platform team saying as an application in this company, we have a way of instrumenting that instrumenting that application so the developer doesn't have to worry. So a lot of times as a developer, you don't, right? If you purely focus on the feature, those platform engineering decisions or SRE level decisions are not applicable to you because it's out of your wheelhouse. Now let's move it forward again. So let's say that you are responsible for that. So let's say that, there's only us three now at Pavan Calc, and we have to support, 1 billion users on Pavan's calculator, right? And so then we will be worried about that, right? And it's like, it's not automatic. Like you have to put the hooks in there, right? Oh, I need to be able to register the transaction, or I need to be able to like generate a span or a trace ID to like report to a system. There are like, it's kind of like a yin and a yang, right? Like these certain monitoring systems can tell for generics, or they can also, depending on the language, they can do auto notation. They can infer certain pieces of data or instrument certain pieces of data. But also, it's like you as a developer, it's how granular do you want to go, right? Like method to method calls, developer has to worry about that, right? Like it's unless like now Java has like notation out of the box, and your ways to inject. Say, hey, we can actually intercept the method calls and time it. But a lot of times, like, that might not make sense. And so, like, part A, like, you might want to time how long does it take someone to add from the clicking 2 + 2. Like, you would put the hooks in there. And this is where it gets into, okay, what are we using? Like any piece of software, you might be using a different technology. Let's say if you're using some distributed tracing like Jaeger, you might have to register those events to Jaeger, right? And so that's where it gets into it's a architecture level decision, but usually as a developer you might be given that. Now if you were just playing with it on your own, right? So let's say that even flip side, like you have full autonomy in what you make. It's a big world out there, right? Like there's lots of learnings. Basically you want to make sure that you want to monitor your application, but also you want to make sure you want to monitor the infrastructure, right? Like there's this thing, it's popular now called Kubernetes. It kind of is the great equalizer, right? Like it used to be your application and your infrastructure were completely different, right? Like it didn't, everything was bespoke. So the person who, I'll go back to my days, like when I started out of university, I wrote like Java primarily. And so like I wrote, JEE, Java Enterprise stuff, and it was run locally, and then it was given to like WebSphere or WebLogic or JBoss. I worked around, so it was given to JBoss, right? More often than not. And like, there was a very big I would say separation between what you wrote and where it ran. Today, like if you're a developer, more than likely you're writing some Kubernetes manifest, right? Like you're able to kind of like say, okay, here's my Java, like Pavan.war. It goes into like a container or an image, and then the image gets deployed. But you're kind of writing some stuff, right? Like there's hooks that you can give, And also, like, as the infrastructure became more generic, right? Like, you're looking at more generic things. It's the whole idea between like a physical machine and a VM, like as a container to a container orchestrator, is that there's a little more generalization, right? Like, unless you're like, you can scale at a different level. Like, I can bring on another pod, or I can bring on another container, versus I need to really understand what's happening in my physical machine or VM. And so that's where it becomes important, right? So, like, long-winded answer, well, how, I kind of lost track of like what the original question was, but went off in the tangent there. But yes, like, usually it's not as important to a developer, but it's something good to know, right? Like, it took me a while in my career to start getting exposed to that. And I would say, like, I was 5+ years into my career before it started making a difference. Like, then I had to start making those decisions, right? Like, oh yeah, we should monitor for that, or oh no, we shouldn't monitor for that, because it takes too much firepower for us to, it doesn't matter to like determine that. So yeah, definitely play with what you got.
So to summarize, implementing observability is a cycle that needs a lot of reinvention until it is refined. Like, for applications, and nowadays it's mostly cloud native. So, like you said, the buzzword Kubernetes is in limelight for this observability implementation, I think. And like, what are the common challenges that developers face when implementing observability, and how developers can overcome them?
Yeah, I think I think this is more of like or of intrinsic answer again. Like, I think what we should treat observability or monitoring or logging as a piece of software, right? It's iterative. It's not, a lot of times if you're a pure developer, you're like, oh, this is, a systems engineer or cloud engineer's problem. And as we know, like the dev and ops, right? So you have left brain, right brain, or you have mode 1 or mode 2, right? If you subscribe to Gartner, that when you give it over to the operation side, there's always a little bit of like don't want to change, because change brings risk, and risk is not keeping the lights on. But if you hand that over to the operations team, there's an air of like air of not wanting to iterate, right? Unless there's something severely broken. Versus, like, it's a journey with this. Like, what do you log? Why do you log it? When do you intercept? When do you not intercept? Really fine tune it, because like these things are not free, right? Like, there is overhead as an engineer. There is overhead when we write to a log. There's overhead when we kind of expose to a tracing solution. There's overhead. There's overhead with a monitoring solution, right? Like, if you need to instrument with a monitoring solution, like, that's 5% overhead, right? Like, as much as they tell you it's low, nothing is free, right? There'll be a cost in product, there'll be cost in resources, there'll be cost in human time. And so, like, always adjusting it. Like, it's just like building a particular feature. And it's like, what do you want to know? Like, now, if you're working for a firm and there's already like some sort of reliability engineering practice, like, yes, we subscribe to the red metrics, or we subscribe to the 4, how many gold? I think it's 4 golden signals, right? Like, of what an application is and how you can tell. Like, then you want to make sure you are providing for that. If you're completely novice, a good thing to look is like to actually like kind of look up red metrics and the 4 golden signals, because like that's kind of where observability science is, right? Like, hey, how do we tell, again, like, based on these signals, like saturation, error rates, response times, and whatnot, are what we're doing, is what we're having, or is what we're building successful? A lot of times it's hard to test out on your local machine too, right? Like it's a distributed systems problem. Like, how do you, if your application takes distributed load, how are you going to mimic that in your laptop, right? Like, there has to be, there is a march to production. But the good thing is now, especially with cloud native stuff, like the parity between what's on your laptop versus what's in like a perf environment. Let's say what you're running on K3D on your laptop, or telepresence somewhere else to let's say like a EKS or AKS or GKE cluster, it's almost similar, right? Minus the scale, or whatever attachments the cloud providers give you. But if you're able to actually kind of like move that along, so there's more parity, and then you can start to see, okay, like we're doing load test on certain things in a distributed way versus. So it's more of a, hey, the same problems you have with distributed systems, like going from like local to a more distributed system, is exactly the same thing. Like, but and how do you validate that? How do you validate that your application like passed the perf test? Well, it's your observability stack will help you validate, right? What are the logs telling you? What are the your APM solution telling you? What is the tracing solution telling you? And so yeah, it's just good being aware of those things, right? And then if you have to add or subtract, working with appropriate people, or if that person's yourself, getting those particular facets set in place.
Great. So we got to know that how important observability is, and how critical it is for the DevOps and all the developers. So, but how does observability contribute to the overall DevOps culture and collaboration between Dev and Ops teams?
It is a common language, right? Like that is a little bit of an odd question to ask, but it's like, again, like observability is not like a checkbox. It's not like I have observability, so I have DevOps, right? Both of those are, or I would say, like DevOps is a cultural thing. There's no like, and observability is a science. It's like, how does science and culture kind of merge together, right? With that, it is a common language, right? Like you can say, hey, you know what, your response time is slow. Okay. And then let's say I'll role play. So for OP, let's say OP was my boss, and he said, "Hey, Ravi, the website's slow." That's actually a common interview question I ask people. It's like, "Hey, our website's slow." That's it. That's all I tell them. And I want to see how they dig in. Like, well, like these services are distributed; these are not. What is slow? Like, what is slow to you, right? It makes the subjective objective. Let's go with that. So OP, tell me my website's slow.
Have to check the logs.
No. I was saying, you did tell me. Okay, so let's say OP did tell me the website's slow. That's very subjective, right? It's like, okay, is it slow for you? Now, like, ironically, we have, I'm owner of a website here at Harness, and we get that sometimes, and it's like, this is great. Is it slow for you? Is it slow for me? Is it slow for everybody? Is it, is there a CDN stack? Like, is it, is there a backend going slow? Like, is our middle tier going slow? So just tell me, like that's the quintessential user question, right? Like, it's slow. Yeah. Good. Like they say, slow is the new down, right? Or I forgot who said that. It's been out for a couple or several years now. But that's it, right? Like, it's like, okay, like that's your that's your subjective feeling. It's slow. For me, it's fast. Well, if we want to turn subjective into objective, where that goes, it's time for science, right? And so it's like, okay, well, let's look at the transaction logs. Let's look at the time between these calls. Let's look at time to first byte, or like if we can measure that, right? Like, let's like kind of look at a whole bunch of things. And is OP full of it, or is something really going on? And that observability portion again is like, okay, because if OP is experiencing slowness, that means we're seeing that something's wrong with our internal state, right? Like that's the door panel gap, slow, right? What are we gonna do about it? Well, let's just start looking. If we had any alerts, that's more monitoring, right? Like if we had any alerts, did we have any sort of outages? Did we have something slow? Did the user, let's go trace what you're doing? More often than not, it's like, you're doing something that we didn't expect you to do, right? Like we're really good at infrastructure monitoring, right? Like that is baked in a lot of places, especially cloud vendors. Like we know how to monitor infra. If something goes down, like it will pop back up eventually. But a lot of times it might be something in the logic, or it might be something that it's all these systems distributed. Go back to the fog of development. Maybe we're used to someone going A, B, C, but you went A to D, so that will cause another, or the call order is off. So this concept called a thundering herd occurs. Like we're getting overrun on one part, then not, we didn't expect the scale here. We expect you to scale somewhere else. And like those type of decisions, like it's not a singular piece of infrastructure is at fault. Like it's just us understanding like how did all the infrastructure, all the particular facets of the application or distributed infrastructure put together, is it firing correctly as we expected? Is it scaling correctly? And that is exactly what we can prove by traces, logs, and metrics, right? So
perfect. So I don't want to take much time, but what are some of the trends or advancements do you foresee in the field of observability for developers?
Yeah, maybe like it's just it's observability as a science is always moving forward, right? Like it's kind of like moves forward with like site reliable engineering as a science, right? Like we continue to refine, we continue to iterate to better the craft for everybody, and it always has to represent like all sides of the table. Like over the last like let's say 15 years, like the application has become much more important than the infrastructure. Like, oh, we have VM monitoring. Like if VM is bad, new VM. Don't worry about the app. Keep putting VM until the problem goes away. Increase load balancer pool. Like stuff like that, right? Like, but the application is super critical. Like it was, but also it goes back to like how quickly can you change? The irony is that it takes a longer time to change the application logic than it takes to scale something up and down, right? Like scaling is like a band-aid at some point. You need to scale. Like, clearly, there's valid use cases. Like anybody needs to scale. There's times of peak traffic and times of not peak traffic. That's all this our elastic world we live in today. But advantage for developers, I think what's shifting is like it's getting closer to the developer, right? And so like Prometheus, for example, like I thought Prometheus was a movie, until I heard like it was something else, or like Thanos or Loki. I thought those were Marvel characters until they're monitoring solutions, right? And so or observability kind of projects, and so it's getting closer to like how I would say like how software is put together. Like those things are sprung from like needs of distributed systems, right? Or like, hey, how do we monitor? How do we allow someone to easily write to Prometheus, or how do we allow someone to easily, like, how do we provide those hooks? I think also like getting the data back to an engineer is important, especially like with the whole like you run what you build or you operate what you write. I actually said it, but like I crossed most of those, but that becomes important because then you have to know, right? And then it's like no one wants to be in production support, right? And like it's like, oh, only when a problem goes wrong. As a developer, you want to validate when a change goes in. And also like where items are headed, it's like when is observability most critical to you, Mr. or Mrs. Developer? It's like, well, we're making a change. It's like, yeah, it's like I am more interested that the feature I wrote when we're rolling it into like perf or rolling into prod is functioning correctly, and that's what I'm concerned about, right? Then observability becomes really interesting. Oh, can I get access to that Grafana dashboard? Hey, can I get access to XYZ solution? Can I get a user seat for app dynamics? Like then it becomes like becomes important, right? And that is what I see like starting to occur, because like it's like the democratization of observability again. It used to be held with like people who focus on the science, like any science. Like there's people who have to be experts in it and focus on the science, but that general expertise, like DevSecOps or even SRE practices, are getting disseminated everywhere. And where does that get disseminated? Well, as a developer, or even a platform engineer or any engineer, that dissemination of expertise happens a lot in your pipeline. So specifically, well, since we're at Harness, I'm a plug here. So that information or that dissemination of expertise happens in your continuous delivery pipeline. For example, hey, you might be scanning, like say you have a CI/CD pipeline, you're building a Docker image of a Spring Boot application. Like you'll typically scan that with some sort of like container scanning solution. Well, that piece of expertise is part of your CI/CD pipeline, like when build scan, and then don't publish if scan bad. Now, how does observability articulate, or how does monitoring articulate into your pipeline, right? Like part of that is very challenging because those systems are external to the pipeline, right? And similar to other external systems. So for that example, that DevSecOps example, you have to wire that in a certain way, but it's showing that, hey, based on certain criteria, do this or that, right? So taking the human decision out of it, the guardrails, is important. And that's something I see as kind of a big change in where it impacts developers. That'll be, they'll be able to see it in their pipeline, is my opinion.
Cool. Some really good insights and trends to look forward. So, yeah, so we talked a lot about observability, best practices, challenges, etc. But let's see how practically it works. Ravi, can you show us a demo of how can we verify our deployments in some sort? That would be really helpful.
Sure. Yeah. Give me a sec here. So. Yeah, let me know when you can see. Oh, there it goes.
Yeah,
See my screen. So this is the mighty Prometheus, what I have here, right? And so we'll start with a blank slate. And so let's say that I'll pretend that Pavan's my boss, and Pavan will say, Ravi, monitor something. So okay, so Pavan will say, Ravi, monitor something, and you have kind of a blank look in your face, like, I mean, I don't use Prometheus, right? So kind of the first thing would be like, okay, like let's go and like just like, you know, like let me see every. It's like this is like select star, right? Like what on earth do I do? What do I have access to? And you're just going to be overridden with number of metrics. Now, where this comes together, and like there's an example that Pavan and I wrote that's on the Harness blog that kind of goes through like, okay, like let's say you were given like a lengthy list of metrics, like where do you start focusing on, and how do you kind of like start including these in a decision that you make. Now, some of these decisions might actually be made for you. Now, in you know, TV magic or podcast magic, I actually wrote an application that writes to two parametrics here. So I write, it's called continuous verification counter and continuous verification gauge, right? These are Prometheus primitives that I'm writing to. And so like, so let's say that I want to make sure that if one of these metrics are, you know, kind of hot, I don't want to do a particular deployment. And this is where the verification step in Harness actually comes in, right? And so I have a particular pipeline. So let me go ahead and kick a new one off. And then this one has just been completed, so it's successful. So I'm going to go and deploy something. So let me go ahead and run a deployment. So this is a Harness continuous delivery pipeline. I'm doing something very simple. All I'm doing is deploying an application into a Kubernetes cluster. I have a sample Spring Boot application that I've written some Kubernetes manifests for. And I'm deploying this with a rolling deployment into a Kubernetes cluster. On the flip side, I'm actually running a verification step here, right? So I'm saying, hey, you know what? Why don't I take a look at these metrics as I'm deploying? And if some of these metrics are a little bit off, based on a comparison of, hey, you know, what was done before versus what is currently going on, or what's been done after deployment, can you help me decide if this has been successful, right? This is going back to, as a developer, well, you really do care like when the deployment's going on, right? Like, hey, you know, what was normal and what's not. Another challenge is, well, what was normal, right? So this goes back to the fog of development that, well, you know, we maybe not deploy every 20 minutes. So I don't know, you know, I'm not constantly looking at this particular facet, right? And same thing with the platform engineering team, or same thing with like a DevOps team, that they're taking a platform-based or more generic approach that unless something's hot, they're not really like, you know, there's not sitting one-to-one. Like you have one service, so you have one developer, you have one QE engineer, you have one DevOps engineer, you have one platform engineer, and you have like one product manager. Like now maybe your service is really big, you know, that might be an exaggeration, but like for stuff that we write typically, a lot of things are much smaller, right? So you can't have like a one-to-one ratio. So people will clearly, if you don't look at it every day, will not, you know, recognize like, oh, this is what is historically in the baseline. So this is what we're configuring Harness to do. Basically, I'm connecting Harness to my Prometheus data source here that we have. So we're looking out for these particular two examples that we have wired in. And we can take a look at what the queries are, right? And so I'm saying, you know what? I want to go ahead and fetch, you know, then this example, again, like it's going to be stable, come to deploy the stable version, saying, hey, bring back a particular metric. This might be average response time, right? Like, or this might be number of users, or this might be some sort of metric that, hey, we typically look at this manually when we are deploying something. And so in Harness, we're able to tie that particular data into a decision, right? So going back to the DevSecOps example, if we have a vulnerability, like say that's a CVE score of 8 or above, that's critical, right? Like don't deploy or don't publish an artifact to the registry or the repository. Same thing here. You can specify in Harness, like, hey, if we come back something that's a failure, or if it's trending towards a failure, which another podcast for another time, you know, kind of the full capability of this is we're using machine learning to kind of look for trending failures. So even more complicated reliability engineering, our area under the curve, distance between two data points. Are we trending towards something that's failing that hasn't been going before? But in this very simple example, you know, we're saying, hey, just give me back the total of this particular counter here. And if it's kind of high, we'll kind of back off on it. So we're going to ahead and just go ahead and deploy this. And so I have two versions. I have a stable and unstable, and also I made an ARM version just in case you're deploying to ARM. Go ahead and going to run that. It's going to run for a while, but let's take a look at something that's actually ran before, right? And so I'll look at the previous execution. It takes a couple of minutes. Now, in my particular example here, it actually is successful, right? Like this is exactly what we want to see. And so taking a look at our particular metrics that we have here, we're looking at a before and after comparison. So saying, hey, you know what? When we deployed before and when we deployed after, the metric was spot on. There's no deviation here. And that's what you're kind of searching for as an engineer or as a reliability engineer or as a platform engineer. You're looking for deviation. Like, hey, you know what? When we deployed the version 1, our data was 1. Now we deployed version 2. If there's some sort of deviation here, like let's say the control data is the previous version, the test data is a new version here, and continuous verification. Was there a deviation? And if there was a deviation, how significant was the deviation? Did the deviation increase or decrease over time? Was there a deviation? No, when the graph is easy like this, it's easy to tell. It's humans, we can tell, but usually it's like up and down or like a little bit wavy, right? And saying, okay, up and down, up and down. And also the previous version would have up and down, up and down, up and down. And so when we're comparing two graphs, we're able to kind of decide, like based on distance, that okay, like the deviation, or there is an anomaly because the deviation is more significant between the previous version with the let's say the canary going in, or the stable being the previous version and the canary that's going in. And Harness will look out for you for that. Harness can do a couple things on your behalf. Harness can actually roll back automatically. It's not unique. This is not unique to any other pipeline in Harness. You can have a particular failure strategy. You can say, you know what, I want Harness to revert, right? Or I want Harness to do nothing. Or I want a Jira ticket to be created. So basically your failure strategy that you have enacted. But I would strongly recommend, like, I don't know if you can send out post link like of the example that we have. It's pretty neat. We take a look at it. I wonder if I can post this in the chat. Let's see. So,
I think we can share it in the comment.
Yeah, I'll share it in the video. Okay. I'll share it in the video. Yeah.
Okay, cool. Yeah, if you want to do, I know I did from Demo Magic there. Like it's, it was kind of pre-built, but if you want to run through exactly what I ran through in some of the some of the settings, why the settings are made a certain way, how you do it. You can look at this. Also, Pavan has an example on the Harness blog that you can take a look at. But
yeah, I'll share those links for people to try. Yeah,
my example.
Yeah, and it was a great demo, Ravi. I hope our viewers today enjoyed and it was useful for them. And yeah, I'd love to see some implementations on Harness and like their application observability. So I think we're almost at the end. And Pavan,
yeah, that was a cool demo, and it was really amazing session with you, Ravi. And thanks for being here in your busy schedule. And yeah, if people like to reach out to you, where are you available on social media?
I'm available on Twitter at Ravi Luck, or on LinkedIn, or you can find me in the Harness community. It's Ravi.
Cool. So yeah, OP, you have one announcement, right? We have some session.
We have an exciting announcement. We have another live show coming up in just about 30 minutes on the Harness LinkedIn page, where Jyoti, our CEO, is going to talk about generative AI, the future of developer experience with Harness. It's an interesting live. Don't miss that out. And it's a product.
Nobody should miss it.
Yeah.
Cool. Yeah. Thanks, everyone. I hope today's session was amazing. And hope to see you all in our next show. Thanks, Ravi. Thanks, OP. Thanks.
Thanks, Ravi. Thanks,
everyone.
Bye.
See you in the next show. Bye-bye.